Welcome to Crying Out Cloud, the podcast that will make you laugh, cry, and reconsider all of your cloud security fears. I'm Eden from the CTO team at Wiz, and I'm here with my fabulous co-host, Amitai. And we are super pumped to walk you through all of the big stories that are happening in the cloud. What is the agenda for today? What are we going to talk about, Amitai?
So first up, we're going to talk about Apple's recent private cloud compute announcement. Then we're going to talk about a potential misconfiguration discovered in Azure Firewall. Then we're going to talk about something called Gitloker, which is a very surprisingly polite GitHub ransomware operation. We're going to talk about Pause Off My Cluster, which is new research from Wiz about threat actors that have been drawing the right lessons from publications about them since they were first busted. And finally, we'll talk about a new RCE vulnerability in PHP that is very prevalent in the cloud.
Sounds lit. Okay, so for the first one, it's Apple's private cloud compute. What happened was Apple announced that they have a new private cloud compute that is to be used for AI processing. What's groundbreaking about this is that everything else that we do with Apple to date is end-to-end encrypted. Like, we have the key and not Apple. And now here, what we're seeing is that Apple needs to be able to read your data to give it as input to an AI model.
Correct.
This is the first time they're doing something of this nature outside of the device.
As far as we know, right?
Yeah.
Like, this is like that's the main differentiator here.
Yes. So what is calling to our attention is something that we spend a lot of time here at Wiz and Wiz Research looking into, which is cross-tenant access in cloud services. So this also piques our interest when Apple came out with this announcement. What steps are they taking, Amitai, to make sure those types of vulnerabilities don't exist in this service?
Let's go through like each of the principles that they mention.
They wrote a very long document, so instead of reading the whole thing, we'll just give you the TLDR.
Yeah, like they basically, it's structured interestingly because they basically go from saying, here are the things we want to be able to ensure, and then they talk about how they go about that.
The first thing they say they're going to do is stateless computational personal data.
That basically means that they are committing to only use the data for its intended purpose, for what the user needs it to be used for, which is as input for an AI model.
Yeah.
That means that they are basically committing not to use this for advertising, for gathering statistics, for stuff like that. This one is kind of difficult to prove out of the box that this is indeed what they're doing, but it does sound like they are very, very committed to it. Another way that they're ensuring this is, which is more technical, is that they're going to be deleting everything as soon as it's used. Like it's going to be like a one-shot thing. And beyond deleting it, they're also going to be using like one-time encryption. So once they're done processing a user's request, they're going to basically replace the keys that they use to process additional requests.
Sounds promising.
Yeah, so I mean, both the deletion and the cryptographic deletion together are pretty strong defenses against an attacker abusing this data, just because they need to have continuous access to their backend to actually make use of this.
The second one is enforceable guarantees.
Yeah, so they want to make it so that anyone, or at least any security researcher, can actually mathematically prove that what they're saying. Yeah,
they said they do.
Exactly. So it's not just empty words.
And they want to make sure you can do math.
Yeah. Yeah. Or they want to prove to you that they know math, because then you'll trust them more. And beyond that, everything is self-developed, or is anything that can be self-developed, like Apple is doing themselves, like they're using their own hardware, their own software. And for the stuff that they are sourcing from elsewhere, then they're like running it through X-ray scans to make sure that they can figure out if, a Chinese threat actor has put in a tiny bug into the board or whatever. Who knows if that actually works, but it sounds very impressive. And they want to make sure that everything they say they're going to do can be guaranteed from a hardware perspective.
The third one is no privileged runtime access.
For, I think, the vast majority of companies or software companies, developers have some sort of access to backend servers. Like you need that whenever something goes wrong, whenever there's a bug or an outage, you want to be able to troubleshoot. And troubleshooting usually means like connecting to the backend somehow and just looking at the logs or looking at what's going on to try to figure out, what happened here. So Apple, and the reason that's problematic is that it can be abused. Because, for example, if I am a developer at a company and I'm working from home, and maybe my laptop gets infected, and then threat actor can gain access to the backend through my computer. And that's why it's somewhat risky. So Apple here are saying, we're just not going to do that. We're not going to allow anyone to connect to these machines. They are going to be effectively like black boxes that the only information that goes into them is the user's request. The only information that comes out are very, very specific logs that are predetermined, and we know exactly what they contain, and we can guarantee that they don't contain any user data. And I guess whenever there's a problem, they're just going to, I don't know, just throw it in the garbage or turn it off or whatever, which is expensive, but I mean, it is more secure.
That's another good one. The fourth one is non-targetability.
The TLDR is that all of the backend components don't actually know who they're talking to. Like everything is anonymized, everything goes through several proxies along the way, and that means that the backend doesn't know who the user is. They only get like a random identifier that changes every time. They don't know what IP address the user is connecting from, and when the user makes a request, then it doesn't communicate with the same server every time. It communicates with a random set of possible servers.
So in order to actually figure it out, you have to take over all of the
Exactly,
servers.
yes. Like an attacker would literally need to be like in God mode to sit like having observability over the entire data center.
I run all the servers.
Yes, I am Apple. And the thing is that if you need that type of access to do
You're
something...
going to be exposed.
Yes.
The last one is verifiable transparency.
Yeah, so that goes back to what I mentioned before about the fact that they want their guarantees to actually be enforceable and like mathematically provable. So they're going to be sharing copies of the software that they're actually going to be running on these backend servers, and they're going to let security researchers like build a virtual version of their data center and just rip it to shreds.
But what they're showing them is still a bit limited, right? Like.
Yeah, so it's still just software. It's not source code. Like they're not. It's not at the level of, let's say, Linux kernel where you know exactly what's going on in there and you can audit the code. There might be stuff that you don't really know exactly how it works, but that does kind of make sense. Like Apple doesn't want to give away their source code because that's proprietary and then someone else could do what they're doing. So I think this is like where they found the balance between security and you know their business interests.
Yeah. I think like reflecting on those that they shared and like their level of transparency behind this, like it's very commendable, but it's also interesting because it's Apple, so they're held to like a crazy standard. What has been the reception to this announcement?
So it's interesting. I think a lot of people were sort of fearful. Like they were like, whoa, suddenly you have access to my data. Mm-hmm. That's not okay. I think that might not be a very proportional response just because I think most of Apple's competitors are already doing this kind of stuff. But like you mentioned, Apple is held to, I think, a higher standard, and people expect them to prioritize privacy above anything else.
Yeah.
What's interesting here is that, you know, the context for them putting out this blog post, which may have been coincidental, maybe not, was that Microsoft had just published about Recall, you know, their own AI feature for Windows machines, and that got a lot of criticism because people were saying that it was effectively like a built-in info stealer in Windows, and that threat actors could just, you know, once they get access to your laptop, they basically have like a history of everything you've ever looked at and everything you've ever read or everything you've ever written.
Yeah.
So I think that context means that Apple were even more under the microscope than they would normally be, because everybody's going to be comparing this feature to Microsoft Recall. Speaking
of Microsoft, let's transition to our second story, which was a vulnerability in Azure. Azure allows you to configure firewalls using service tags. Service tags are meant to like simplify your network isolation by allowing you to group like IP ranges. So instead of adding a firewall rule that would be like only allow access on port 80 from this and that, you could create a rule that said only allow these IP tags. So the thing is that maybe a little bit of miscommunication on how these work, or misunderstanding by the people that were using them. The IP addresses that were owned by Microsoft, that are where they operate certain services, people were under the impression that if they limited to those IP ranges, that was enough, but it wasn't enough.
Correct.
What was happening was you were actually allowing access from other Azure customers, which goes back to what I mentioned a few minutes ago, which is the ever-present fear of cross-tenant access.
Exactly.
This reminds me also of what happened at Amazon with the confused deputy vulnerability class.
Yes, it's very similar.
Yeah. Do you want to talk about what Amazon did when they had their...
Yeah, so Amazon had a similar issue at the identity level.
Yeah.
Like, this issue is a network thing. Amazon had something similar at the identity level where they gave you policies or suggested policies that you should use to allow you to use certain services. And a few years ago, there was an issue that was discovered where the default policies allowed any Amazon customer to use those services against other customers. It was called confused deputy because you're basically deputizing Amazon, and the deputy is now confused. It's doing the wrong things and it's working against you instead of helping you.
Good naming on Amazon's part.
I think it wasn't Amazon. I think it was actually like a security
Researcher,
company that came up with it. Yeah. Anyway, very good naming.
Good naming.
In that case, what they were able to do was they added another field to the policies that, beyond just saying allow access from this service, it was allow access from this service as long as I'm the one requesting it.
So it was attached to an ID.
Yeah.
Which I think the interesting thing is, now in the past few minutes we've spoken about Apple, we've talked about Azure, and now we've talked about Amazon, and the question is, are they learning from each other? Are these CSPs, are they coming up with best practices that are really maintained, and someone else makes a mistake, and then do we look internally and make sure we're not propagating the same class of errors?
It seems from Apple's blog post that they're doing a lot right, and it looks like they're learning a lot of lessons from the mistakes of others, and they're doing everything really by the book, and they're doing a lot of things that would have neutralized past attacks. I do think that the CSPs have more room to learn from each other. We're still seeing similar vulnerabilities pop up every now and again. In this case, the transition from confused deputy at the identity layer to the network layer isn't especially straightforward. The physics are a bit different. It might be difficult for Microsoft to actually implement something similar to the ID field at the network level. It might even be impossible. What Microsoft have said here is that this is just a misconfiguration on the customer's part. You should always have authentication in addition to the network filters.
Microsoft didn't change anything. They pretty much were this is an awareness problem, and this is a
They said we'll make the docs clearer. And we'll make it,
suggested edit.
Yeah, I mean, look, what you could do is you could alert customers to cases where they're using service tags and have a little pop-up that says, make sure they're using correct authentication. But again, this is difficult to monitor for. It's difficult to enforce because it's different layers. The authentication needs to be at the app layer. The firewall is at the network layer.
Yeah.
It's hard. Security is hard.
Yeah. Gitloker attacks. This is an interesting little story where there was a ransom operation against GitHub repos. There was a soup of these attacks, and pretty much what happened is they used stolen credentials. They got into your GitHub account and wiped the content. But what's interesting is they left a README file saying, if you want your data back, pretty much reach out to them on Telegram. But what was cause for a lot of amusement is the letter said, I hope this message finds you well. They've just deleted your entire GitHub repo, and you're probably not doing well.
Well, you were well until you read it.
Until you read it. So is this effective? Is this working for these attackers? Is this something that we're going to see more of because it's an effective method, or no?
It's sort of weird because I feel like GitHub repos that are very likely to have copies, either in the form of forks or in the form of clones. And there's a very good chance that they might the attacker might encrypt the entire repo or delete the entire repo and all of its history, but developers are going to have a copy on their local machine from the day before, and there might be forks, from a week before or a few days before. So the chance of this actually deleting the only copy in existence of this project is pretty low. So I doubt it's an effective attack vector. But maybe if they target like really small projects, or maybe if they target projects that don't have many forks or projects that haven't been maintained in a while, then maybe the impact might be higher in those cases.
So the TLDR is protect yourself, use MFA so they can't steal your creds, have good security, prevent this in the first place, probably have some backups.
Yeah, that's pretty much it.
Bada bing, bada boom. Pause off my cluster. From in-house, we got Pause Off My Cluster from a group of amazing researchers at Wiz, where they found a cryptojacking campaign that targets misconfigured Kubernetes clusters. Attackers pretty much went and leveraged the fact that there was anonymous access on these clusters that were attackable, and then they deployed Darrow miners onto the cluster. And what they did that's also quite interesting and novel is that they hard-coded their wallet and mining pool information, so they avoided being detected, which alludes to the really interesting element of this story is that actually CrowdStrike found this activity about a year ago. And then they published a post explaining the behavior, and then the attacker read the post and was like, how do I now keep doing this, but all of the indicators that they exposed about me, how do I cover them up? So they went, they learned their lessons, and now they're back, but they've done it in a more stealthy way.
Yes.
What did they do exactly to become more difficult to identify?
So this is something that I think threat actors do all the time. Like whenever something gets published.
They create Google alerts about themselves. And
they should, if they don't. That's another feature request. They draw lessons from blog posts about them, from reports about them, anything that becomes public, whether it's IOCs or an understanding of what they're actually doing, their TTPs, they're going to use that to make it harder to find them next time. And that's kind of the trade-off of publishing things. On the one hand, you publish it and then you create awareness about it and then people know to defend themselves. But on the other hand, threat actors are in the audience too, right? So in this case, a few of the things they did that we found interesting were, A, as you mentioned, they hard-coded the crypto wallet. The reason this is useful for them is that then when they execute the malware, they don't have to give any arguments in the command line. The second is that they registered a few domains that were fronting crypto mining pools so that the connections weren't directly to the mining pools, but instead, first, they sent a DNS query for the domain, and then they would have gotten to the mining pool. Now, again, this would have only tricked detection that was based on domain reputation. It wouldn't have tripped up detection that was based on actually observing the connection to the mining pool, to the IP address of the mining pool. But again, that's like one thing that they can do to make it a bit more difficult to identify them. And the last thing they did, which was really effective, is they used something called UPX packing, which is a defense evasion technique where you change the way that your binary presents itself to make it more difficult to understand what's actually going on inside. And that's another thing that they did.
Well, gotta give it to them. It was smart. So what are the takeaways if you've got some Kubernetes clusters that you don't want someone's paws on your cluster?
So generally, in this case, the crux of the matter was, that the Kubernetes clusters weren't configured properly, and they allowed anonymous access. That's not a good idea, especially not in production.
Bad idea.
Yeah. So there are two things you should do here. One is you should make sure that Kubernetes clusters are configured properly, and in particular, you should not allow anonymous access. You should only allow access if you pass authentication. And the second is that API servers are very sensitive. They allow plane level control of what's going on in the cluster, deploying pods, stuff like that, which is what this attacker abused. And there's no real reason for that to be publicly exposed to the internet. You should have a firewall in place that prevents access to just anyone and only allows access to those connecting from a specific VPN that you use to configure your cluster.
Smart. Also, if you want to read more about this, there's a very thorough blog, the Wiz blog, and then you can get all the details of how they did this. For our fifth story, we have a vulnerability in PHP. It is a remote code execution vulnerability. Pretty much an unauthenticated attacker can execute arbitrary code.
Against PHP websites, essentially.
Yeah. Who is affected? This isn't all PHP users.
Correct. So this is only exploitable under specific conditions. One is PHP has to be running on a Windows device. And second is that this only affects PHP if it's running in CGI mode. PHP has a few different modes of operation. CGI is one of them, and it only affects that one.
PHP vulnerabilities are important because PHP is very prevalent and it exists in a lot of cloud environments. It's also very old. Side note.
Which significantly raises the chances of it having these kind of vulnerabilities in the first place. Like,
yes.
This vulnerability is actually a bypass of a similar vulnerability from 2012.
Ancient. Mm-hmm. And it's being exploited, this vulnerability in the wild. There's one group called Tell You the Pass. And pretty much they encrypt files and then they demand ransom for decryption. So suppose you have PHP installed.
Which very good chances you do, because our data shows that PHP can be found in 75% of cloud environments, and around 40% of environments are susceptible to this vulnerability.
So statistically likely.
Mm-hmm.
A patch was released beginning of June, so update to the latest PHP version. There's also some like temporary mitigations you can use.
Yeah, you can use rewrite rules, or you can just disable PHP CGI and switch to another mode. So while this vulnerability probably affects many instances, it's probably only exploitable in a few. So you should definitely prioritize the cases where you're using PHP CGI and cases where PHP is deployed on Windows.
Sounds good. That's it. What are the takeaways for our stories today?
All right, so for the Apple story about private cloud compute, I think it'll be really interesting to follow this story and see what new information they come out with and what guarantees they provide to actually do the things that they say they're going to do. And it'll be interesting to see, once they release the images of their software and security researchers start looking through it to see if they can find any issues. I think it's really interesting and very, very innovative, and I'll be watching closely.
Me too.
For the misconfiguration in Azure, like we mentioned, make sure that if you're using service tags, that you also have application level authentication on those instances that are protected by the firewall. And for the Gitloker attacks, same old, have MFA, have backups of your code.
And write very proper emails.
Yeah, and always be polite. That's also true.
Yeah.
Even when, especially when threat actors are, that's the bar.
When you're attacking, yeah.
Like if a threat actor is polite, you can be polite.
Absolutely.
Right? So for Kubernetes clusters, make sure that you have disabled anonymous access unless you absolutely need it, which you really don't. And make sure that you have a firewall in front of your API servers.
Yeah.
Because nobody but you should be able to access your API servers.
And lastly, for the RC vulnerability in PHP,
patch while prioritizing cases that are actually exploitable, which means Windows servers running PHP in CGI mode.
Rad. Okay. That is all for this episode of Crying Out Cloud. If you enjoyed the show, be sure to subscribe and share a link to the podcast, but not your cloud keys. And as always, if your cloud security strategy is making you cry, don't worry, just cry out cloud.